Looking at part two, something I want to note before we get back into this, these were actually taken directly from Khan Academy, and I'm even saying right here, for additional practice, make sure you do precisely defining rigid transformations until you feel really comfortable with all the different types of problems it offers, because it does offer quite a bit. Now, these problems are a little tricky because we have to not just identify a transformation that happened, but actually all the transformations that could have happened under this mapping. So it's really important you pay attention to the order of what you're being given. So this maps W to X, and this maps Y to Z. And the question is, what could have happened? Well, the first thing to note is that we know it couldn't have been a rotation. If we want W to X and then Y to Z, that's going to require two different centers. So it's not going to be that. So we can explore translations, we can explore reflections. And so one inclination might be this, a translation. So like we take this vector Y to Z, and if it's the same vector for W to X, we're in business. So what I'm going to do is just copy this and then paste it. And let's see if it actually is going to be the same vector. And so it's the same vector for W to X. We know that it has to be a translation. And lo and behold, it is. So that is going to be at least a translation. But if you look at that, it looks suspicious like those vectors are not only the same, but they can be split in half. And so if we consider like the halfway point in each vector, which is roughly here, I'm just roughing it out, it looks like we can also draw a line of reflection in such a way that it's perpendicular and the same length. So we actually have two transformations for this. One thing could be is actually reflection, and the first thing it could be is a translation. Okay, where the thing is drawn in on the mapping itself to prove that what we think it is actually is. Let's go over here and check out transformation omega. That's what that symbol means. And we're going to ask ourselves the same questions. What could this be? Well, I know for sure it cannot be, if it's going A to A prime and B to B prime, I know it can't be a translation because this translation line wouldn't be the same for both. It could actually go in different directions. So it's not a translation. If it's a reflection, we can test that out. Let's consider the BB prime line and the A prime line. If I look at the midpoint of both those lines, I actually am going to have a line of reflection that goes right down the middle. And make sure you get your flu shot if you need it. So we definitely have a reflection going here. Okay, so now the question is, can it be anything else? Well, here's something interesting. If I look at the A prime B prime line, and I look at the A B line, they do meet right here. Now, if they meet right here, that implies that I actually could draw a circle using that as my center, and that could travel A to B, and we can draw a concentric circle from A to A prime as well. And so this can not only just be a reflection, but this can also be a rotation as well. So each of these first two actually have two different things they could be. Okay, let's look at this one. A goes to A prime, B goes to B prime. So A goes to A prime, B goes to B prime. So this one goes here, and this one goes here. So right away, we know it's not a translation. Looking at the positioning of the points and how these lines are, we know it's not a reflection either. So that only leaves one thing. Using the crossing as a center, we can kind of rough out, and that's a terrible circle. Pretend it's better. We can actually rough out two circles, which makes this a rotation. All right, so one more. We have A going to B, and C going. Let's see. A goes to B. Oh, B maps to A. Sorry, I have backwards. B maps to A, and C maps to D. Well, that can't be a reflection because it doesn't share the same lines, but they are going to be a translation. They have the same vectors. All right.